Hello everyone and welcome to this latest video discussion as part of the RICS Tech Partner Programme. My name is Andrew Knight and I've been with RICS for 13 years now. I currently sit within our thought leadership and analytics part of the organisation, and my role is to look at the impact of AI, data and technology right across the built and natural environment. And with over 110,000 qualified members working worldwide, right across that life cycle, from land use itself through planning and development, construction, brokerage, valuation, finance, building operations, building surveying, it's a really wide canvas upon which AI, data and tech is having a huge impact. And indeed, our members work with all the major asset types, whether that's land itself, infrastructure, offices, residential, retail, all the alternative assets. It's a very, very broad canvas upon which data and tech, as I say, is having a huge impact. And it's great to have René back on the call again. We spoke a couple of years ago initially, I think, so it's really good to have you back on the discussion. And before we sort of kick off, it'd be great just for those of you who didn't pick up that original conversation, just a little bit of your backstory and just a very quick introduction to Alice Technologies.
Hey Andrew, it's great to be back. I really look forward to talking to you today. My background is I'm a second generation civil engineer. When I graduated high school, my dad gave me a good piece of advice. He said, son, study anything you want, just don't do civil engineering. So I thought I was lost, now I'm found. So I went obviously to study civil engineering, global construction experience, underwater pipelines in Beirut. Went to Afghanistan as a civilian. That's kind of an interesting one. Designed, built, procured my own jobs. Went to did the cruise ship terminal in Amsterdam, a bunch of projects in San Francisco, LA, all over the world. Gas refinery in Abu Dhabi. Ended up doing a PhD at Stanford. I currently co-teach the main construction management class there. I did my PhD in artificial intelligence applications for construction. I started that in 2009. It was a pretty prescient move in some ways, given the buzz surrounding AI and construction. When I started working on Alice in 2015, people were like, "What do you mean AI for construction?" Like, like the venture capitalists were like, "We wouldn't touch this with a 10-foot pole." Like, absolutely not. Like, construction tech, con tech? What on earth is con tech? Like, no way. Like, absolutely not. Thank you. Have a good day, sir. You know. That changed in 2017, 18. What is ALICE? ALICE is an acronym that stands for Artificial Intelligence Construction Engineering. So basically, it's the first system in the world that optioneering system for construction schedules. You can upload schedules, run them, simulate them, change them, and so on and so forth. That's what you can do with ALICE. And yeah, look forward to telling you about it today. There's obviously been a big release that we came out with, I think 6 weeks ago at this point. We've been really cooking up a storm for about 18 months. And yeah, look forward to telling you about Alice Core, which is our latest product.
Well, indeed, I think that was going to be my opening question, actually, aside from the kind of backstory piece, was really to tell us what Alice Core is and I suppose what it is and why this is important to the construction industry, given what you've already put in motion over the last few years.
Mm-hmm. I think that when people look at construction scheduling, they're going to see it as having developed in 4 phases. One, it was paper and pencil. Then it was done using Gantt charts, so CPM, the regular standard sort of construction scheduling tools today. I think then we as a company developed this 3D-based constraint programmer. So you could import a BIM, set up the constraints on the BIM, and you could import the BIM, set up the constraints in the BIM, and then run lots and lots of simulations off that. And it was parametric. So what BIM did for design, Alice did for construction, in the sense that in BIM, you can change the height of a column and everything in the model updates, and the cross sections updates, elevations update. Well, with us, you can simply change the number of cranes. You can change the design. You can change the overtime. You can change the work density. You can change all these kind of, constraints. Just hit the button, it resimulates, and there's a little video that gets built. That was the 3rd phase, the sort of 3D-based visual constraint approach. The 4th phase, I believe, is what we released 6 weeks ago. We've been working on it for about 1.5 years. what we did was we sat down and our clients were saying, guys, we really love we love the vision. We love what you're building. We love the fact that it's AI. We love the fact that we can simulate, rapidly iterate, all of that stuff is great. We love the juice, but we're not that, hyped about the squeeze. It takes us, 4 weeks to set it up, 8 weeks to set it up, somewhere in that vicinity, right? It's a big lift. It's a big setup time. So we sat down and thought, okay, well, what do we do? Right. On the one hand, we can continue doing what we were doing, automating the 3D version. The question we asked was a lot more bold. The question we asked was, well, would it be possible to take this 3D based algorithms optimization, approach and apply it directly to a list of tasks? I.e., import an existing schedule, which is Oracle Primavera P6, and literally hit simulate and generate millions of different ways of building it. That's exactly what we released 6 weeks ago. We've actually partnered with Oracle. We're members of the Oracle Partner Network, and we have kicked off. We basically kicked off the ability to ingest existing schedules, and then within minutes start doing optimizations and simulations.
So I guess fundamentally, in a tremendously good way, I would always say, you've done this because this is kind of what the market wanted. That they either didn't always have a BIM model, or they actually wanted to have this sort of quicker startup time and go to kind of the raw material of an existing schedule from P6, and just get cooking more quickly, I guess.
100%, yeah. It's also 100% integration with their existing system. So I have a friend who's a philosopher, and he listened to me for a little while, and he said, "It sounds like you guys have brought heaven to earth." And I thought to myself, that's an interesting way to view it. But we took all this sort of power, this incredible sort of ability of these AI algorithms that we've developed to optimize construction processes. We've taken that and we've literally enabled you now to apply it directly to an existing schedule. It's kind of like the best of both worlds. And what's fascinating about it, Andrew, is that when we started on this, we had the draft designs in January of last year. By March, someone in the company asked me a question, and I said, I think you'll be able to get 70, 80% of the quote juice of the optimization ability. And now that we've released it, you can get 98, 100, 100%. There's certain things you can do with this approach that you couldn't do with the old one, and vice versa. But you can do pretty much any of the simulations you could run before. I really can't think of anything you can't do. Everything from changing production rates to increasing work density to changing the available labor to resequencing to shuffling resources between tasks to increasing, decreasing float in order to change the number of people that you need to build a project in a given time, reducing duration. All these levers are still available to you.
And you obviously still have the original platform, the original solution, Alice Pro. I mean, given the kind of differing adoptions of BIM by region, does this represent either a shift away from BIM or just a recognition that there is a very kind of uneven sense of BIM adoption, both within countries and obviously on specific projects by specific sponsors?
That is a great question. And so let me kind of give you some contextual background here. My PhD advisor at Stanford, Martin Fisher, his license plate says 4D CAD. So, we are definitely one of the departments that have been pushing for BIM. We see the advantage of BIM. There's no question that BIM is the future. I think that if the question is BIM the future or not, I think that really the question is yes, but when, and how do we get there? And so what we view is not a replacement to Alice Pro, the 3D software we call Alice Pro. We view it as a stepping stone for the industry to get there. Interestingly enough, what we're actually prototyping right now is the ability to go from quote 1D list of tasks to import a PDF to 2D, then from there to get to 3D. And I actually think, like, now that I see it, I'm like, oh, it's one of those, like, oh, it seems obvious. Why didn't we think of it? But yeah, I mean, our head of product who joined us from Autodesk, within a few weeks of the company said, guys, you're sort of 7 to 8 years ahead of the market. Now, we don't want to be at the market. We're obviously innovating, but we want to be, a year, 2, 3 years ahead of the market. And that's what this 1D solution is. And I think that 4, 5, 6 years out, you're looking at 2D PDFs, that kind of stuff. And then you can actually then, import it 3D. By the way, something really fascinating that kind of blew me away is I thought to myself, like, oh man, like it's unfortunate, right? We now are using a list of tasks, so we can't use the 3D anymore. One of the few times that we have actually just tried something and it worked was literally we ingested a 3D. We scheduled it on 1D. We scheduled a list of tasks, and then we're like, oh, could we just simply add the 3D model back to it? We just simply added it to it, grouped the tasks to the element, just like a 4D software, and hit simulate. And so I think what I'm trying to explain is I think that you need to have fluidity between 1D, 2D, and 3D systems. This is the learning that I think that we are the first in the world to have figured it out, that you don't want to just be like, it's only 3D, nothing but 3D. You have to be in 3D or you're dead in the water. I think it's more of a question of, okay, how early in the process are you? Do you have a massing model or not? Do you have a 3D or not? Do you have any drawing? Like, okay, well, I only got a list of tasks. Great, let's start with that. Now I've got some drawings. Let's add those to the mix and ingest it into the system. Now let's add a 3D and ingested system. And this sort of dynamic level of detail approach, right, or dynamic dimensionality approach is what I think is going to end up happening to the industry.
So really, I'd like to go back a couple of steps. You mentioned that you've actually partnered with Oracle on this and are part of their network. And I guess one of the things that maybe it's a personal view, but I talk to so many people in this sector, and there's this kind of frustration among the kind of client side about the fact that they're ending up with just a multiplicity of solutions and a whole bunch of things they're trying to knit together. And I'm keen to understand what kind of benefits to both sides you get from being part of a network with something like Oracle, and obviously how that flows through to the customers as well.
Look, Andrew, let's be clear. When Oracle came out with a solution in I believe it was 83, right? Like the concept of using a computer to schedule anything was like, what the bleep, right? Like, why would I, why I got this in my head, right? So I think what I'm trying to explain is, let us not forget, right? Let us not forget the contribution that Oracle has made to our field, that Primavera specifically has made to our field. I don't think it's fair to just sit here and ding them. At the same time, like, we're the younger generation, right? I started my PhD, I think I was 28. So, my job is to sit here, look at existing technologies, just like Oracle did in 1983, and said, hey, this is the status quo. We think we can improve upon it. And so I think that there's a couple of points I'm trying to make. One, let us be clear that what Oracle brought to construction was a huge leap forward. We went from effectively paper and pencil to suddenly being able to like model things in a computer. That's a big deal. Right, I call that going from static, which is paper and pencil, to automated. What Alice does, it takes us from automated to parametric, and from parametric to generative. Parametric is you can change things, change parameters. Generative means the computer changes those parameters for you. It tries all the 10,000 simulations that are on the table. In terms of the interplay between Oracle and Alice, first of all, let's be clear. They are a market leader. They've been around for literally 41 years at this point. And so they have a huge market share. They're also interested in pushing the industry forward. They have been very friendly with us. They have really, like, they support startups. They support the ecosystem. They want to see the industry move forward. And if you combine those two, if you combine their existing market share, the fact that everybody's familiar with it, the fact that a lot of the contractual, the legal framework, everything revolves around their software, and the fact that we're bringing this new age, cutting edge, AI to the table, I think it's a great combination. And they've really, like, hats off to them. They've been great partners. They brought us into their network. They haven't been like, oh my God, these guys are competing with us. They haven't tried to put us out of business or anything. They've really been like really great. So nothing but positive things to say about them.
So, in addition to obviously sort of partnering with something like Oracle, what else do you think this new version of Alice, this Alice Core, will do to broaden the market you serve? Clearly, we've talked about the kind of BIM versus P6 as the kind of input, but how else do you see this kind of broadening your market?
I mean, you're able to take an existing schedule, ingest it, and then just optimize that what they have. I mean, that the use case means that anybody with an existing schedule can literally ingest it and hit play and start running it. I mean, that's basically the use case. I'm not sure if I understood the question fully. You go from having to like set it up in 3D yourself to like just saying, hey, whatever you're using today, give it to me. Like, even here's an example. You come into a project that's halfway complete.
Mm.
And they're like, oh, we never used a BIM. Like, yeah, sure, maybe we should have, we shouldn't have, but like, whatever, it's water on the bridge now, we're halfway through. Okay. You've got two options. You can either create a BIM for the project, which we can do. We call it SIM, construction information model, a crude 3D representation of what you're building, right? Okay, we can do that. I'm gonna set up your project. It takes several weeks. Or, hey, just give me a schedule. Like, which would you prefer?
And one thing I'd like to do, actually, particularly for the benefit of those who didn't watch our first discussion those couple of years ago, is you effectively, with the original Alice, defined this new category of construction optioneering. And it'd be great to actually kind of unbundle that really in terms of really effectively the benefit that brings to general contractors, owners, sponsors, because it's one thing to sort of create that description, but it's kind of, how do we unbundle that? What does it really do? And what are the benefits for those participants?
Here's a question I have for the listeners. Imagine you could build it before you build it. So this is an example that we actually give to our students at Stanford and say, look, here's a I think it's a 60-second or 30-second video of an orchestra. And this orchestra is playing this music. And we say, okay, great. Here's a question to you. What would that orchestra sound like had these musicians just met for the first time? Let's assume they've got the music sheets in front of them. They're playing Beethoven's Fifth. And you're saying, okay, what would that sound like? And the answer is like, probably not very good. And so that's kind of where you are in construction. You literally are you say, hey, we're building a $350 million hospital or £350 million hospital. Great. Let's kind of figure out how to do it. And you're sure you're creating a schedule, you're creating an estimate. But my question is, okay, how many scheduling options have you looked at? I can tell you, like, one of the top companies in that field, Mortensen, will look at 3 options. The thing that you can do suddenly, right? And imagine the cost of exploring an option was 0, right? So here's a question. Let's say you take a fresh graduate from civil engineering, and you say, hey, go build a 4-story building, and they go build it. And you go, okay, cool, now build it again. You'd expect that they've learned something, right? You'd expect that the second time around, they figured out maybe a better way to do it. You say, okay, you know what? Try build it again. Try build it again. Try build it again. Maybe 4, 5, 6 times in, they've like really sort of ironed it out. Well, imagine you can do that in a computer. You could literally simply say, build it with 2 cranes, build it with overtime, build it with overtime, the steelworkers in the month of October, reduce the number of people, try to level my resources, try to make sure there's no spikes in the resources, try to make sure the resources come on site and leave on site as close together as possible, so they're not waiting around twiddling their thumbs. Increase the crew utilization on this project. You know what? TBMs are really expensive. Can you minimize the number of TBMs? Like, you can optioneer it. You can just build it 40 different ways before you build it. And what's interesting about that, originally we thought, hey, the point of Alice is that like you run the simulations and then you find, it produces dots. Each simulation is a dot on a cost time graph. And so you grab the best dot and you victoriously, hold this dot above your head and say, guys, like, I found it. This is the best possible dot. And what we've really realized is that that's not how humans work. Instead, when you have run those 40 different ways of building it, and this maybe an hour or two of time, you start to understand how the system behaves. Humans are really good at pattern recognition. We really suck at like crunching numbers like constraints. Yeah. So our software, our scheduler, crunches constraints for you. Suddenly, what you realize is that as you're crunching these numbers, you get a feel for what are the key variables that affect your system. And so you're like, oh, I think that the key variable that affects my system is number of crews, or here's a good one, right? So hey, just add another crane. One of those early 5 years ago. Very cool. We added a crane. They ran it. Well, nothing happened. Your software sucks. I'm like, okay, well, hold on. So then we look at it and we're like, oh, guys, but you didn't increase the number of steel workers. Like, what's an additional crane going to do if there's no one to basically serve it? Oh, yeah, okay. Well, add a couple of steel. Oh, shit, we could have 4, 5, 6, 6 steel crews. Oh, okay. Now, this is what I'm saying, right? Is that you can start uncovering, the interaction between various different variables in your system.
Indeed, and I know from sort of past discussions that Alice has initially had the best kind of take up on kind of the infrastructure side of things, tunnels, rails, and kind of data sensors, oil and gas pipelines. Why do you think those kind of asset types have been sort of particularly, it's resonated particularly with those kind of challenging structures?
Well, let's be clear. I mean, a $300 million hospital is not unchallenging. And so it depends on the type of project, the type of challenge, I guess. So historically, we've focused on infrastructure and industrial projects, and we focus on projects that are 100 million and up. With this latest release of the software, because of the fact that the setup time has gone to like 1 hour or 30 minutes, the size of the project has reduced substantially. Now, what I've explained is that the size of the project that we've targeted has changed because of the fact that the setup time is 100-fold less. So that's the first part of my answer. The second part of my answer is that industrial and infrastructure projects historically have had much greater interest in optimizing production. And so if you look at a schedule, for example, for an oil and gas facilities, it's oftentimes uses budgeted labor units, production rates, it uses resource loading and stuff like that. The more data there is, more fidelity in your schedule, the more optimization we can squeeze out of it. Like if you say, I'm going to build a project, a hospital, and it's 300 million, let's use pounds as an example, but this is a 300 million pound hospital, and I have one task that says build hospital, and that task is 4 years long. There's not much I can optimize for you, right? Like, it's a build hospital. Okay, great, right? But if you give me a schedule that says, here's a 6,000 activity schedule, and I just got off the call today with someone that's doing one of the largest oil and gas companies in the world, 2,600 activity schedule for a project. I didn't ask the value, actually. I should have done that. But I think 80% of the activities had resources. And I mean, we were showing the magic. I mean, they were like, hey, we really don't like the waving of the resources. Tick, 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 boom, leveled it out. Okay, we really don't like the fact that we need 1,200 people. Okay, well, here's what it looks like. You can build it for 650 people, still achieve duration. For 600, you'll lose 100 days. Oh, okay. And that's the kind of stuff that you can start doing with this.
And in terms of, I guess bringing it alive, particularly for people perhaps who are listening from the UK, I know you've done a fair amount of stuff on the HS2 project, the high-speed rail. Can you talk us through what's that looked like in terms of the use cases there?
Yeah, it's on our website. There's a case study. So if you go to Alice Technologies, I think we did the with SCS or 100. You'd have to look up the case study. I think we saved them 2 million by giving them a resequencing option.
Yeah.
Yeah. Okay. Yeah. There we go. Align JV optimizes HS2 Coal Valley, and I actually I'm not sure I have the information in my head, but maybe you can just download the case study if you
Yeah,
want. But
I'll put the link when we publish the video, René. So
mhm, yeah, it's optimized the sequence for it. There we go. One of the areas the team explored most deeply was the finish the sequence and procurement of the viaduct's deck. And basically, what we did was we modeled the procurement for the deck, and then told we call it unleashing Alice.
yeah.
And so we basically told the software, yeah, it's there's what the schedule tends to have is a lot of these hard constraints. If you relax them in the right way, you can literally be like, hey, try all the different sequencing options, and Alice will say, okay, well, I'll try 6 million sequencing options. Is that enough?
And it seems to be you have made some great headway in the UK. Is there something particular about the
Mm.
UK market in terms of its willingness to take on this kind of tech, or the nature of the projects? What's been the kind of
We
secret sauce there, do you reckon?
That's a great question. So 50% of our revenue is UK based. Um, Maybe 40, I'm not sure, but it's a pretty high number. We serve four main markets: US, Canada, UK, France.
Mm.
Those are four main markets we serve. I actually think there's a number of reasons. I think one, I remember back when I was doing my PhD, there was like something coming from the government that basically mandated the use of BIM.
It did, yeah, yeah. That was a big driver for the UK market as ever. If you drive from the top like that, you're going to get a lot of adoption, not just for government contracts, but generally around the sector.
Yeah. So I think that was a interestingly, when I heard it, and this is like a deep dark secret, I was like, yeah, what difference is that going to make? But here I am, 10 years down the line, I'm like, oh, I guess it made a difference, So I think you guys were ahead of the curve on that and the adoption of BIM and technology. And I think also when you're looking at generally the UK construction industry, you guys are, because we've done projects globally. I mean, we've done Mexico, Brazil, Chile, Singapore, Malaysia, Japan,
Mm.
South Africa. We did on the Antarctic, believe it or not. We did France, Spain, Prague, all through the US. Like we've seen construction globally. The UK construction industry, I would say, is ahead in terms of the like how to explain it. The process you guys will use production rates. You guys will have a process model. You guys will actually have data, right? You guys will store information. Your project management is far more processized than other countries. And so when somebody comes and says, "Hey, I can improve your process," it's like the answer isn't, "Well, I don't have a process. I'm just kind of shooting from the hip."
Mm.
Well, yes, and we're less of a great solution for you. Whereas, no, we actually have a process. We really are fine tuning it. Oh, this is great. You can help me further fine tune it. That's what the UK is, I think, ahead of. And I think part of the reason is what I said is that government mandate that you guys had sort of pushed people to adopt, BIM back in the day.
So I guess to finish, a couple of kind of slightly more general questions, if I may, Renia, about kind of AI in the sector. I mean, one of which is just, obviously, generative AI has captured the zeitgeist and kind of woken not just the construction sector, but a lot of the built environment sector up to the whole kind of potential of AI, albeit in other forms rather than necessarily generative AI. I mean, how do you think, at the risk of trying to make you make predictions, I mean, how do you think the market is viewing kind of the utility of AI, and what do you think that will look like perhaps this year or the next? What's the evolution there? Are we just in a bit of a hype moment, or has the sector really kind of grasped that there's a lot more they should be doing?
Yeah, Andrew, I've been at the bleeding edge of R&D in Silicon Valley for 15 years at this point. So I was a professor at Stanford for a few years. I'm a lecturer there now. did my PhD there. I know a lot of people that worked or founded, some of the top name companies, both on the investor side and the company side. So I've lived through several of these quote hype cycles.
Yeah.
If I'll give you some examples. Go back when I started the company in 2015, big data, I think was 2016, 17. Everything was big data. Then there was a hype cycle, which was neural networks was another one. Everything was neural networks. And then that was closely combined or followed by machine learning. Now it's LLMs, large language models. So what I'm trying to say is that when we say that we're in a hype cycle, that doesn't mean that once it sort of the hype dies down, the technology goes away. Because big data came and is here to stay.
Yeah.
People don't even think of it as big data anymore. But if you look at how much data the typical company is crunching, it's really remarkable. The second thing is that, yes, there could be a hype cycle, but that doesn't mean the technology is going anywhere. So that was the first point. The next point I'll make is, okay, so what does it actually mean for us? So let's take a look at what LLMs can do and what they cannot do. That's really kind of the question that you're asking me. If you look at neural networks are not new. They've been around since the 60s. What is new is the number of neurons that these neural networks have. So if you look at GPT-4, it runs off a 1.7 trillion parameter model. But that's telling you is 1.7 trillion is 1,700 billion, right? Or 1,700 million millions.
Million, yeah.
Just for you to understand the scale of that, there's 10 billion people on the planet. So it's 170 neurons per person on this planet is the size of the thing that the brain that has been developed. Neural networks have had a very, very useful property, which is you don't need to explain to it how to solve the problem. You don't have to explain to it how to write poetry. You don't have to explain to it how to identify a cat. You don't have to explain to it how to run an analysis. That's a neural network. They have two substantial disadvantages. One, it can't tell you how it solved the problem. The answer to how it solved the problem is in the value of those 1.7 trillion parameters. The neural network can say, yes, I have figured out how to identify cats. And the way I do that is, neuron number 1 has a value between 0 and 1, and that value is 0.3. Neuron number 2 is 0.342. Neuron number 3 is 0.3.
Exactly. That
is the answer to how I figured out what cats are, which is not very useful for humans. The more, I think, interesting one, and the one that's more, I think, apparent, is that neural networks are never 100% accurate. Even something like GPT, or I should say GPT, right? Even something like that doesn't have, still makes, hallucinations. With billions and billions and billions of dollars that are going into, Facebooks and Googles and OpenAIs and all the systems that are available out there. And so what I'm trying to say is, okay, so now that we've looked at, hype cycles and the fact that, yes, there's a hype and there's less hype, but the technology is there to stay. So same thing's going to be with LLMs. There's hype, there's less hype, but the LLMs are not going anywhere. What I think is if you look at what they can do and they can't do, what you come to realize is, wait a minute, what they're really good at is like ingesting a lot of data and summarizing or analyzing lots of data, right? I think a friend of mine who's used to work at PARC, the Palo Alto Research Center, one of our advisors, really, really, has a company with like 12 top-notch PhDs working in AI. And he said the way you want to think about LLMs, the way you want to think about ChatGPT is it's an omnipresent summary, right? Or omnipotent summary. And that I thought was like super interesting. It's like it can crunch a lot of stuff and give you mostly the right answer.
Yeah.
And that's sort of what it does do. But that doesn't solve engineering problems. You can't send a satellite to the moon where it's kind of mostly the right answer.
Yeah.
It's okay when you're drawing a painting. It's okay if you're creating an image or writing an essay, it's definitely not okay when you want things to 100% work in the real world. And what I'm trying to explain is that there's these two ways to solve problems. One is using these large LLMs to kind of, get trained and then answer things. You don't have to explain to it what to answer, and you don't have to explain it to what to answer. You don't have to tell it how to do it. The other way of solving things is using engineering, using math. And so what I think you're going to start seeing is a combination of these quote old school and new school technologies, the combination between neural nets and classic search algorithms, AI, between math and, tell me, like, search my database for my company, answer these 5 questions so I can feed them into my structural analysis program that then runs, mathematical equations to solve ABC.
Yeah.
That sort of, back and forth interplay between these two is, I think, what you're going to start seeing.
Yeah, and I guess that's a big thing the market needs to get its head around, that AI is not one thing, it's a kind of set of tools that will probably be blended in that way and used to get what we need, but there isn't one kind of silver bullet there, is there?
It's funny you say that. So, like, when you talk to folks that are not in Silicon Valley or don't, haven't spent 20 years working in AI, a lot of times they'll be like, well, is that really AI, or is that the real AI? Or, you talk to folks like, my buddy Philip, right, who worked at Park. He's been working on AI for 20 something years. And so to him, like, is it really AI? It's sort of like, well, what, it's algorithms.
Yeah.
Right? It's just a different brand or flavor algorithm. There's these types of algorithms, those types of algorithms, there's LLM algorithms, there's neural nets, there's machine, there's like, and that's a very, very broad field of algorithms. And so it's interesting that you've noticed that, like, that. Yes, exactly. Like, what is AI? Like, in the common sort of, zeitgeist of the moment, AI is I think I read a definition. AI is whatever wasn't AI 3 months ago. Right? But it's just algorithms at the end of the day. Like, we've designed them. They do what we designed them to do. And it's exactly what you're saying. Like, you will end up combining and recombining various approaches to move this thing forward.
Indeed. And a final question to kind of bring us back down to work in the construction sector. I mean, obviously you've been doing a huge amount of work with Alice on the whole kind of scheduling piece, but as AI continues to spread, what do you think from the construction sector are the next kind of killer use cases where AI can add some real value, as you've been doing on this kind of optioneering thing?
I think that, like, the low-hanging fruit is, if you look at companies like Parspec, I believe .io, a colleague of mine at Stanford. So crunching large amounts of information and rapidly giving you correlations or analyses or insight into that large amount of information. I mean, that's the lowest hanging fruit, in my opinion. So Parspec, for example, looks at your lighting specifications and then automatically matches you to manufacturers and specific products in those manufacturers' offerings. Super cool, I think. You look at someone like Trunk Tools, and what they do is they basically go to you, ingest your project's information. Like, here's 50 megabytes of 50 gigabytes sort of data, and then you can literally ask it whatever question you want to ask it. You're like, hey, how many windows are there on the 10th floor that satisfy these requirements or these specifications? So that's the kind of stuff that I think you're going to start seeing rapidly diffuse through the industry.
Fascinating. Well, René, I've taken a huge amount of your time today. I really appreciate your insight and your commentary on what's still a pretty fast-moving sector. But for today, thanks ever so much for your time. I look forward to catching up again.
Thanks so much, Andrew. Always a pleasure talking to you.
And you.